Hello everyone, let's talk about tension in this video. Firstly, these two people, they are not contact with each other and there's a rope between them. So the tension in this rope, they transfer forces between these two people, between them, and the tension, obviously you will see the tension is pulling this person and pulling that person. Okay, so the tension acts in two directions. The tension acts in two directions. So therefore, tension is think as a strength and not a force. The difference between strength and the force is because strength is a scalar. Because they have two directions, so there's no single direction for the tension. Okay, so it cannot be considered as a force, because force is a vector and there will be a single direction. Should be single direction. Okay, and because the tension, I think you can see the tension, they got two directions and they have the same size. Okay, so they can be considered as a action and the reaction pair, because they have the same size, same strength, the size is the same sizes, but they are in opposite directions. Okay, how can we find out the tension? We need to apply the thing we learned. Okay, apply free body diagram, FBD, or the system and the environment view to find how big the tension is. Okay, for example, if we choose this person as the system, and then the tension become external force acting on this person. Okay, and then if we can find the tension here, we assume tension is the same size inside of the stream. So if we choose this as a system, okay, the tension become external force. Okay, and then if we find this one, the tension here, and all the tension inside of the string will be the same. So the tension have the same size inside of the string everywhere. Okay, the same strength. And let's conclude the concept of tension. Okay, and let's use two examples to talk about the tension. First, there's this one. This one is in SciPad, page 121. As you can see, we have a ceiling and we have two weight. Okay, so this is weight 1, so I can say W1, and we have weight 2, so W2. Okay, and the tension between the ceiling and W1 is 1, and the tension below is T2. Okay, so we want to know how big for these two tensions, T1 and T2. So how big is T1? We apply the free body diagram. Okay, so if we choose W2 as the system, so what forces are acting on W2? I think you know it's gravity. So this is gravity W2, which will be mg. Okay, and another one, then T2 become the external force. Okay, so T2, and because W2 is stationary, okay, so you know the upward force equals to the downward force. So T2 will be equals to W2, which is mg. Okay, and if we put the number in, it would be 3 kg times 9.8, and from calculator equals to 29.4 Newton. Okay, and now what is the tension for T1? If we see W1 and W2 as a system, and the forces acting on the system will be gravity, and the gravity now is how much? Is W1 plus W2. Okay, and then also, and the tension is what? The tension is T1. Previous T2 become internal force, which doesn't have any influence on the system. Okay, it's inside of the system, internal force, so we don't need to worry about it too much. Okay, so our system becomes like T1 and the total weight. Okay, so T1 will be how much? So T1, because the system is not moving upward and downward, okay, so T1 will be equals to W1 plus W2, and which will be 3 kg times 9.8. Oh, okay, so it's 29.4 Newton. Okay, so this will be times 2 will be 58.8 Newton. Okay, so as you can see, the tension of T1 and T2 are different. Okay, so the important concept here is normally we assume we can ignore the mass of the stream. Okay, so all the tension will be the same value inside of the stream. Okay, but if we need to consider, in reality, if we need to consider the mass, we need to consider the mass of the stream. And as you can see, T1 in this position, they will need to support more mass. Okay, comparing with T4, for example. T4 is here, so T4 support less mass. Okay, so these are the extra mass between T1 and the T4. Okay, so the mass here will be bigger and gradually decrease, become smaller. But if we assume if the mass can be ignored, okay, it's too small, the thin string, and then we don't need to worry about the different size of tension inside of the stream. Okay, this is what this question can teach us. Okay.